Okay, so as in the last video, we have talked about the image formation by lenses. So in today's video, we will be discussing about thin lens formula, which is also known as lens equation. Alright, so let me write here the topic first. Today we will be discussing about lens equation, lens equation or thin lens formula. Lens formula. Alright. So this is also known as thin lens formula, lens equation. Alright, so what is this equation actually? Let me write here down the equation first. So this equation is 1 over f is equal to 1 upon p plus 1 upon q. Alright, 1 upon f is equal to 1 upon p plus 1 upon q. Here p is what? P is for the distance of the object. Alright, so let me write here down. P is for object distance. Object distance. Alright, then again let's see what is this q for. Alright, so this q is for image distance. Alright, this p is for the object distance and q is for image distance. Alright, I'll be showing you with the help of diagram as well. Distance. Alright, and f is what you people know, that focal point or principal focus, as I told you in my previous class as well. Alright, so what is this formula? The relation between these three things is called thin lens formula or equation, like the relation between this focal point or principal focus and p, which is the object distance, and q, which is for the image distance. Alright, the relation between f, p and q is called lens equation or thin lens formula. Alright, so we'll talk about their relations. Alright, so here I am writing f as well. What is this f? F is what? F is here focal point. Focal point not, but focal length. Alright, so this is the focal length. Now let's see by the diagram. I'm making here the diagram. Alright, this is the biconvex lens. Here we have what? Principal focus. Alright, this is the principal focus. I know my diagram is not straight, but when you will make on a rough register, that will be straight. Alright, so for suppose if I do have object, wait, let me label these all first. So here I have the focal point. Here I will have, wait, here I will have center of curvature. Alright, wait, I'm not making the center of curvature here because this will create mess now. Alright, so here I have create a focal point, as you can see. Alright, so I am putting here one object. Alright, we'll form the image first so that we can find the equation, or we can drive this equation. So here we'll apply our two rules. When the light ray going parallel to the principal axis will always pass through the focal point. So here this is going parallel to the principal axis, and it will always pass through what? Always pass through focal point. Wait, this is not straight at all. Yes, this is fine. So it will always pass through the focal point. Again, second rule, when the light ray passes through a optical center, it always reflects back with the same path. Wait, this is not straight. Not straight. I don't know how to make this straight. Alright, this is a little bit straight, I guess. Alright. So here, as you can see, the light ray is going from the optical center and that is reflecting back with that same path. Alright, so here as you can see, we do have a right angle triangle. As you can see here, we do have a right angle triangle. This is the principal axis. Here we have base. Here we have hypotenuse. And here we have perpendicular. So this is what? This is a right angle triangle. Alright, so here for suppose if I am going to give the points to the object, like the name of the object is what? Here it is A and B. Alright, A and B is the name of the object. Alright, so here as you can see, their meeting point is here somewhere, means the image will be formed would be here. Alright, so here I am going to give the names to this ray as A prime and B prime. Alright, so the object is AB and the image is A prime and B prime. Alright, similarly here as you can see, we do have one right angle here as well. Alright, so here we have the hypotenuse, this is the base, and this is what? This is the perpendicular. Alright, so now we know that. Wait, let me tell you. As we have written P for the object distance. So as you can see here, wait, let me use another color. Alright, so here the distance of the object is what we call the P. Alright, and the distance of the image what we call the Q. Alright, so here we have P and Q as well. Alright, and let me write here about the focal point as well. As you can see here, from the optical center to the focal point or principal focus is what we call the focal length. Alright, so now I have written each and everything. Now just we have to write the formula. Now as we know that in the right angle triangle, wait, let me make it so that I can explain you with that. Where should I make? Yeah, here it is fine. Alright, if I have this right angle and if I have this one, wait, this is very big. Alright, so as you can see, these are not same but these are similar. These aren't concurrent but these are similar. Alright, just because here we have 90 degree, here we have 90 degree as well. Alright, their theta are similar. Alright, so they have similar theta, which means angle. Alright, so for suppose this side, if I have wait, A, B, C, and this I have A, B and C. So what we will have, let's see. Alright, so we will have this ratio would be equal to this ratio. Alright, we know that these are not same but these are similar just because of the angle. Alright, so their ratio would be equal to their ratio. So this is the rule of the right angle triangle. So we are gonna apply this rule to this figure as well. As we have seen, we are having two right angles here in this picture. Alright, as you can see here, 190 degree is formed here. Here would be angle. Alright, and here would be angle as well, and here we have again 90 degree. Alright, so now let's drive the formula. Alright, we have to drive this formula. Wait, we have to drive 1 upon F is equal to 1 upon P plus 1 upon Q. Alright, we have to derive this formula. Now the triangles AOB, wait, let me tell you. The triangle AOB, alright, is equal to what? The triangle AOB and this A dash, O and B dash are similar. Alright, and we have talked about their rule as well. We are going to follow that. So let me, what do we have similar? Alright, triangle AOB. So let me write here AOB, and as you can see there as well, A dash O B dash. So A dash O B dash are what? They are similar. Hence we are going to apply that same rule, like corresponding sides ratio would be same. Alright, so let me write here down. So if I'll take the ratio of this A, B, so that would be equal to the A dash and B dash. Alright, so let me write here, their ratios would be equal. So A dash B dash ratio AB. Alright, here we are going to take B dash O. Similarly, we are taking base. Alright, so here we have to take base as well. BO. So first in the numerator B dash O, in the denominator BO. Alright, so this is the first equation we do have, where corresponding sides ratios are equal. Alright, so here, wait, let me use another marker. So here BO is equal to P. Wait, I'll tell you by using that diagram. And B dash O is equal to Q. So BO, wait, as you can see here, BO is equal to P, and this B dash O is equal to Q. So we have to just replace it. Alright, that would be same. A prime B prime upon AB is equal to, instead of B dash O, we have to put Q. So Q upon BO, we have to put P. Alright, so this is the second equation. Alright, so now we have to go again. Now again we'll have two triangles. How we'll have two triangles again? Right angle triangles. So here, of course, we'll have a normal here. Alright, here we'll have normal, and here then again 90-degree angle would be made. Alright, again here 90-degree angle would be made. Here would be some angle. Alright, as you can see here in this diagram only now. Only in this diagram. Alright, so 90-degree angle, and again here we'll have any other angle. Alright, so now let me mention here first. Now what angle we do have, I should mention this with pink color, that is fine. Alright, so similarly triangles CFO and A dash F B dash are similar. Wait, I am telling you by that diagram. Okay, CFO, as you can see here, I am going to give the name to this C now, to this, wait, to this as C now. Alright, so COA, not COA but CFO. CFO is equal to what? It is equal to wait, let me tell you this. A prime, this f, and this b prime. Alright, this a prime, f, and b prime. So here I have written that, and here let me make the ratios first. So again, a prime b prime upon co. Wait, let me tell you that. As you can see, a prime b prime and this co. Alright, let me erase it. We have taken that ratio as alright. Then again, b prime f. Wait, let me tell you. B prime f will be equal to what? B prime f will be equal to OF. Alright, it will be equal to what? It will be equal to OF. So here I am writing this again. B prime f is equal to OF. So this is what? This is equation number 3. Okay, so now as we know that here is what? CO is equal to AB. As you can see here, this CO I have considered as AB. This CO, because the length of this CO is equal to the length of this AB. Alright, so why should not I mention this CO as AB? Alright, so I have mentioned here. Alright, again we have B dash F is equal to Q minus F. How? Wait, let me check. So B dash F, as you can see here, B dash F, this whole is equal to Q, and if I do minus Q, this distance if I do minus, this F distance if I do minus, so only this would be remaining. This whole is Q. If I do minus this F distance from this Q, only this would be remaining. So why should not I write Q minus F? So wait, I am going to write that down as well. Let me erase this. Alright, so instead of that I have written Q minus F. Then again what we have now, the last one, FO is equal to, or OF is equal to what? It is equal to F. Let me show you. As you can see, OF is equal to F. Alright, and I have written that. So let me put the values now. Alright, so wait. A prime B prime upon, instead of CO, we'll put AB. So we have put AB is equal to, instead of now what? Instead of B prime F, we have to put what? Q minus F. So here we have Q minus F. Instead of OF or FO, we'll put F. Alright, just because of this. So now here we have our fourth equation. Alright. Okay, so now as you can see, the left hand side of this equation and this equation is same. Alright, A prime B prime upon AB. Alright, so by comparing equation, wait, let me write here. Equation, what? This equation we do have 2 and 4. So by comparing equation 2 and 4, what we will get, we'll put this value Q upon P. So wait, let me change the color. Alright, so Q upon F is equal to, then we'll put this value Q minus F upon F. So now we have to remove this Q. Alright, initially I am going to separate these. Alright, so Q upon F is equal to, F would be there in the upon of Q as well, and F would be there in upon of F as well. Alright, so as you can see in the equation, in the thin lens formula, we don't have Q in the numerator. In all, we have 1 in the numerator. Alright, so here for removing Q from the numerator, what I'll do, I'll divide these both sides with the Q now. Alright, so let me do this there now. There. Alright, So let me write this equation again. What I have, q upon f minus f upon f is equal to q upon p. Alright, I have written that same. Now by dividing q from both sides, let me write this first. By dividing q on both sides, on both sides. So let me divide here q upon f. Initially I'm going to write this all same. Alright, then I'll put q. I'll tell you p. So now I'm going to put this q. Alright, so now we have to divide q from both sides, on the both sides. So here would be q, here would be q as well, and here would be q as well. So now they will be cut off. Alright, this q would be cancelled with this q. Alright, this q would not be cancelled just because in the numerator f is there. So this f would be cancelled. Alright, and this q would be cancelled with this q. So now what we have remaining? Let's write there. Nothing is remaining in the first, so we have to put 1 upon f is remaining in the denominator. Then again minus, nothing is remaining in the numerator. We have to put 1. Wait, we have to put 1, and in denominator q is remaining. We have written q. Again is equal to nothing is remaining in the numerator. 1 upon p is remaining in the denominator. So we have written q. Now as you can see, this is minus here. When it will move there, it will be plus. So 1 upon f is equal to 1 upon p plus 1 upon q. So here we have derived our formula. Alright, this is what? This is thin lens formula, or which is also known as Lense equation. Now see, we have this q as positive. So this is showing what? This is showing that we have used convex lens, and convex lens always provide what? It provide real image and inverted. So this is showing that we do have real image. But what if we'll have minus sign here? So we'll have, if we'll have minus sign here, so we'll have our image that would be virtual. Alright, in which we would use concave lens. So let me write that point, as that is very important. If minus q or q is negative, what I'm writing, if q is negative, then image is what? Image is virtual. Alright, so here we have derived our formula, which is also known as thin lens formula or Lense equation. So this was all for today.